Hello, everybody. It is Thursday, April 9th, and we are going to talk today about taking a two-dimensional cross-section of a three-dimensional object by slicing it. So I'm going to show you what the cross-section is, because it's kind of hard to explain. And I'm going to show you with Play-Doh. If you happen to have some Play-Doh at home, feel free to follow along. Grab your Play-Doh, grab a plastic knife or a butter knife or something to cut it with, and we're going to see exactly what a cross-section is. So let's see how this works out. So a cross-section is a two-dimensional slice of a three-dimensional object. So I'm going to start with a rectangular prism. So I'm going to take my Play-Doh and I'm going to make it into a rectangular prism as best I can. And I'm going to slice it. So what I want to determine is all the different two-dimensional cross-sections I can get from a rectangular prism. So, I feel my hand's blocking it. First, I'm going to slice it horizontally. So if I slice it horizontally, I want to see what two-dimensional object I see. So I'm slicing it horizontally. And basically what you're looking at is the face of the object. I'm not looking at the three-dimensional shape, I'm looking at the two-dimensional shape. What shape is that? That's a rectangle. All right, so if I cut it horizontally, basically if I cut any prism horizontally, the base of the shape is going to be the cross-section. So one two-dimensional cross-section of a rectangular prism is a rectangle if I cut it horizontally. Let's put it back together. Next, I'm going to take a cross-section by slicing it vertically. So I'm going to take it and I'm going to slice it through the top. What two-dimensional shape am I going to get? Slice, 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 slice. I'm looking at the face, the two-dimensional face that you see. This, again, is a rectangle. This is a longer rectangle than the previous rectangle, but it's still a rectangle. Now, what if I slice it diagonally through the side? So I'm going to take it, I'm going to go diagonal now. And what I have is another rectangle. A rectangular prism has a lot of rectangular cross sections. There's one more cross section we're going to do here. And that is diagonally through the base. I'm basically going to cut the corner off. So it's a little bit hard to see with the Play-Doh, but we'll do the best we can. So I'm going to cut this corner off as best as I can. Now it's a little bit hard to see, but what I end up with here is a triangle. You can kind of see it. So if I slice that corner off, I'm going to end up with a triangle. And there's a type of intelligence called spatial intelligence. Spatial intelligence is being able to kind of see things inside your head. For those of you who are better spatially, you can kind of see it in your head, but if you're not so good spatially, it's really helpful to see these objects, and you can kind of see the triangle that I cut up there as well by slicing the objects up. So for a rectangular prism, most of the cross sections are rectangles, but if I cut the corner off, it is a triangle. Next, we're going to do a cylinder. We're going to start with a horizontal cross section. And we said for the rectangular prism, whenever I cut it horizontally to the base, the cross section will be the same as the base. So a cylinder has a circular base. So when I cut it horizontally, we see that the two-dimensional cross section is a circle. My circle looks a little fat, but it's all good. Now, oh, my hips are getting sore from this. Next, I'm going to slice it vertically. I want you to think about what shape we're going to end up with if I slice it vertically. the two-dimensional cross-section, when I cut it vertically, is a rectangle. If I slice it vertically through the top, I'm going to end up with a rectangle. Next, I'm going to slice it diagonally. So I'm going to slice it diagonally through the side. And we're going to come up with a shape that you've probably never heard of before. What we have here, you might be thinking, you might be saying, well, that's an oval, Mr. Schlansky. Yes, it is an oval. The mathematical name for this shape, though, is called an ellipse. An ellipse is essentially an oval. You've heard that word before. If you've ever been on an elliptical machine at the gym, your feet are going in an elliptical motion. And also the Earth's orbit is elliptical. It's an ellipse because it's not going in a circle. It's going more in an oval shape. So if I cut it diagonally through the side, a cylinder, I end up with an ellipse. And that's it for cylinder. Let's move on to cone. Again, I'm going to do the best I can here. I have bigger Play-Dohs at school, but I can't really go there right now. All right, let's start by slicing it horizontally, parallel to the base. I want you to think about what shape it's going to be. Hopefully you have your guess. And when I cut it parallel to the base, when I cut it horizontally, I have a circle. What about when I slice it vertically through the top? I want you to think about what shape I'm going to have when I slice it vertically through the top. Did you guess triangle? Because it is a triangle. Now I'm going to slice it vertically, but through the side, not through the top. And what I have here is a shape you kind of have heard of before. This is something you learned back in Algebra 1. It's a parabola. A parabola is, it's not a triangle, it's curved up top. A parabola is a cross-section of a cone when I slice it vertically through the side. Next, I want to slice it diagonally through the side. Similarly to the cylinder, when I slice it diagonally through the side, it's the same as the cylinder cross-section. It's an ellipse. And those are what you need to know for the cone. Pyramid's gonna be very hard for me to make with this Play-Doh, so I might just kind of skip it, but we can kind of talk about it. Yeah, it's really hard to make the pyramid. But if I slice it horizontally, it's going to be a rectangle. If I slice it through the top, it's going to be a triangle. If I slice it diagonally, it'll be a rectangle. There's one shape left. Fortunately, my hips are getting really sore sitting on the floor like this. And that is a sphere. And a sphere only has one possible cross-section. No matter how I cut this thing, the two-dimensional cross-section is a circle. So I hope you understand the concept of what a cross-section is. It's a two-dimensional slice of a three-dimensional object. Depending on how I slice a specific shape, I will get different two-dimensional cross-sections. So let's take a look at some examples that are in your volume and three-dimensional objects packet. I'm kind of stuck. Let's see if I can manage my way to get up. Ooh. I made it. So this is cross sections in your volume and three-dimensional objects packet. Let me just put the Play-Doh away, because if not, then my son is going to be very angry at me, and my wife will be very angry at me if I waste the Play-Doh, because he likes to play with it. And fortunately, he's not eating it, so that's always a plus. Hopefully, you're not eating it. So let's go back to the sheet here. So again, this is cross sections from volume and three-dimensional objects packet. William is drawing pictures of cross sections, the right circular cone below, because that's what we all like to do in our free time, right? We like to just, draw pictures of cross sections. Which cannot be the cross section of a cone? Well, if I slice it horizontally, if I slice it horizontally, it's going to be a circle, which I don't see here. If I slice it diagonally, it's going to be an ellipse, which would be correct. If I slice it vertically, it's going to give me a triangle. If I slice it vertically through the side, it's going to give me a parabola. There's no way to get a square or a rectangle cross section from a cone. Everything's curved in a cone. There's no way to get these straight sides. So the answer would be choice 1. Number 2. Which is not a possible two-dimensional cross section of a cylinder. So a cylinder, I can get a circle by cutting it horizontally. I can get a rectangle by cutting it vertically. I can get an ellipse. I stole this question from somewhere and they had a typo. So an ellipse I would get if I sliced it diagonally. A triangle, there's no way to get a triangle from a cylinder. A rectangular prism, I can get a triangle by cutting the corner off, but I can't get a triangle from a cylinder. Which type of shape can represent a two-dimensional cross section of a sphere? Again, there's only one possible cross section of a sphere. No matter how I cut it, I end up with a circle. Why don't you try number 4 and 5 on your own right now? I'll give you a moment to try 4 and 5 on your own. Okay. Number 4, which figure can have the same cross section as a sphere? Well, a sphere can only have a circle as a cross section. That's really sloppy. That's like sloppy even for me. A sphere has to have a circle. So I can't get a circle from a rectangular prism. I can't get a circle from a triangular prism. I can't get a circle from whatever this thing is. I can get a circle from a cone if I slice it horizontally. And again, you can't really see it in 2 dimensions. That's why I spent the time and I cut the Play-Doh for you so you could actually see where the cross sections are coming from. Number 5. Jennifer is trying to determine if there is any difference in shape for various horizontal cross sections. She works with 2 cones that are similar to the one pictured below. Jennifer takes a cross section of the first cone that is parallel to the base of the cone. So parallel to the base means slicing it like that. Next, she takes a cross section of the second cone that is slanted 5 degrees from parallel. So she means like that. What were her results? The cross sections were both circles. Well, the horizontal cross section should have been a circle. The diagonal one, the slanted one, should be an ellipse. So the first cross section was a circle, the second was an ellipse. Choice 3 is your answer. Number 6, a right cylinder is cut perpendicular to the base. So perpendicular to the base, what does that mean if it's perpendicular to the base? Well, parallel to the base would be horizontally. Parallel to the base would be horizontally. Perpendicular to the base is talking about vertically. If I take a vertical slice of that cylinder, it's a rectangle. And finally, the last one, a pyramid is sliced horizontally into 10 solids of equal height. Let's see if I can draw a pyramid. I have a lot of trouble with drawing pyramids. I don't know why. Did I do good? Thank you. Sliced horizontally. So they're slicing like that from the top to its base. So it's slicing like that, then like that, then like that, then like that, then like that. So first of all, are they circles or are they squares? Well, if you're cutting it horizontally, it's got to have the same cross section as the base, which is a square, so it can't be the circles. And I'm going from top to bottom, so as I go from top to bottom, the squares are getting bigger and bigger and bigger because the biggest square is at the bottom. So your answer is choice 3. I know you went through the whole thing together. It's just about understanding. There's no math to it. It's just about understanding what a cross section is. If you have trouble seeing it in your head, you know, get some Play-Doh, start slicing it up, and hopefully you'll be able to make that connection. I've got a quiz for you on this. It's one question. Just get it done. It should be quick. And we're going to talk a little bit about cross sections throughout the rest of the unit. That's why I wanted to put this lesson in here now. So again, a cross section is a 2-dimensional slice from a 3-dimensional object. And the best way to do it, I mean, is really just to physically take something and do it. So if you're taking a test or something in the future, hopefully look back to this video of Mr. Schlansky in his basement with all the boxes, with his Play-Doh, slicing it up. Have a good day. If I can figure out how to get out of here. Stop share.